Hi, sir.
Hello, Haripriya. Acha, we were doing this one, na? SHM. Acha, this part is clear to you, no? The SHM part that I have taught you. Yes?
Yes, sir.
Okay. You don't want me to revise it?
It would be better if you revise.
Okay. Acha.
Because it's been so long since you attended physics.
We'll revise it once again. See, the simple harmonic motion is a kind of periodic motion, the motion which repeats itself. That's known as your simple harmonic motion. Okay. Now, the common example that I have given was a motion in which a particle is starting from a point, it's rotating, it repeats its motion after it has moved like this, coming from here, rotating, then again coming to this point, original point, then again repeating the same motion. This is a kind of periodic motion. But I said every periodic motion is a simple harmonic motion, but every simple harmonic motion may not be a periodic motion. Why? Because every periodic motion, simple harmonic motion itself is a periodic motion. Okay, like the motion which repeats itself, simple harmonic motion also repeats itself. But there is a one difference between simple harmonic motion and the periodic motion. That is, in simple harmonic motion, there is always a force which is always acting towards the mean position. That is the only thing which makes the difference between simple harmonic motion and the periodic motion. Okay. Now, since I said a simple harmonic motion is a periodic motion, so we can, every simple harmonic motion is a periodic motion, so that we can relate simple harmonic motion equation with a circular motion type of equation. So that's why the time period I have given as 2 pi by omega, and when I have compared them both, I have found out that I can write the simple harmonic motion displacement equation as y is equal to a sine omega t. Okay, clear up to here? Why? Because it is rotating with angular velocity omega. So theta will be equal to omega t. So y will be equal to this amplitude a, which is the radius of the circle, a sine omega t. Tan theta. Okay.
Sir, will harmonic motion always be circular?
Yes. It can be compared, can be always compared with the circular motion.
Yes, sir.
Because simple harmonic motion is a periodic motion, always. And circular motion is also a periodic motion. That's why we can compare it always. Okay, then that's why we write the equation of simple harmonic motion as y is equal to a sine omega t or y is equal to a cos omega t. You can write both of them. Now, when we talk about the simple harmonic motion, actually I have told you in y direction, this one, but we will be taking it along the x-axis. That's why I have written the x displacement of the simple harmonic motion as a sine omega t, because it's the general equation of simple harmonic motion in which x denotes the displacement from the mean position. What is the mean position? Mean position is the point where net force is zero, equilibrium position. So the x represents the displacement from the mean position, and that a is the amplitude. Amplitude means the maximum distance from the mean position where it can move, right or left. Omega is the angular frequency. That's all. This is displacement we can write. Now, if I have asked you any one of you to find out the velocity in the simple harmonic motion at any point, what you'll do? You know the displacement x is equal to a sine omega t. To find out the velocity, you just have to differentiate x displacement with respect to time, right? Clear? Haripriya, Diva, Karishka, clear to everyone?
Yes.
Okay.
Yes.
Then velocity we can find as dx by dt. So it will be, when we differentiate, we'll get a omega cos omega t. That represents our velocity, which I can write like this, because a omega cos omega t can be written as a omega root cos square omega t, and I can write a omega root over 1 minus sine square omega t. But when I take a inside, it will become omega root over a square minus a sine omega t whole square, but a sine omega t was displacement. So I can write the velocity as omega root over a square minus x square. Just look at this equation, how I have framed it. Okay. Okay, now everyone understood? So from here, what we have understood, that in a simple harmonic motion, the maximum and minimum displacement that a body can do from the mean position is two amplitude position, because a will be, x will be maximum and sine omega t is maximum, means cap plus a or minus a, that these are the position of a and b here and here. And velocity, when we talk about the velocity will be maximum, if you see this equation, when x is equal to 0. Because if you have any value of x, that will decrease the velocity only, and v will be maximum when the x is equal to 0. Correct? And x is equal to 0 means what? That's the mean position. So from here, what we have understood, the velocity in a simple harmonic motion will be maximum when the particle is at mean position, and that value is plus or minus a omega. Why we write plus or minus a omega? Because 1 plus represents one direction, minus represents the other direction. In the similar way, when will be velocity minimum? When x becomes amplitude a, at that point it will become 0. That means the velocity will be minimum at corner points, at a or b. Because by logic, if you see the particle is starting from O, it will move on and will reach the point A. At point A, it will reverse its direction. When it is reversing, it should come at momentarily rest. Similarly at B. So that means at the two corner points, the velocity will be 0, and at the mean position, the velocity will be maximum, that is a omega. Okay, clear up till here? Haripriya, okay?
Yes, sir.
Okay, Kanishka, okay na?
Yes, sir.
Diva, what about you? Okay?
Yes, sir.
Okay. Now coming to the acceleration part, velocity you have found. Velocity was a omega cos omega t. Now when we want to find out the acceleration is what? You differentiate velocity with respect to time, you'll get the acceleration. It will be dv by dt, and when you differentiate, it will become minus a omega square sine omega t. But a sine omega t was displacement here. So when we write it, it will become a is equal to minus omega square x. So acceleration in simple harmonic motion is minus omega square into x. Omega square into displacement, and if we it is negative sign. That means what? If the displacement is towards right, acceleration will be towards left. When displacement is towards left, acceleration will be towards right. And if we talk about force, mass will be mass multiplied with this minus m omega square x. And here we are getting one thing. Initially, if you see, I have told you, in simple harmonic motion, the force is always directed towards the center, mean position. If you see here, if the particle is moving right, displacement is right, the force is towards left. If the particle is moving left, x is negative, the force will be right. That means the force is always acting towards the mean position. That's what the definition of simple harmonic motion. Okay. So the maximum, and if we talk about the maximum acceleration, it will be again when x is maximum, that's a minus omega square a and plus omega square a. Okay, towards the end positions. Up till here it's okay, na? Clear? Displacement you have learned, velocity you have learned, acceleration you have learned. Again confusing. Haripriya, is it again confusing?
Sir, a little bit tough.
See what you have to do now. If you want to understand it better, you have to derive these relations by yourself. If you want displacement, you know x is equal to a sine omega t. If you want the velocity differentiated according to you, then you do it, then analyze it. At what point it will become maximum, at what point minimum. Similarly, then go on to find out the acceleration. If you do it by yourself, you will be able to understand it better. Otherwise, there will be a problem because these equations are looking like it's too much. But they are simply nothing. They are just calculations using x is equal to a sine omega t. I'm just going on differentiating using my whole concept and then analyzing it. Nothing much. Okay, I'll suggest you to do it at home by yourself. These are again all the results only. When we are talking about energies, acha, what about Diva and Kanishka? Diva, is it okay for you? क्या हुआ? You guys are sleeping. Diva, okay? दिवा की आवाज ही नहीं आ रही. What about कनिष्का? कनिष्का, तुम्हें समझ में आ रहा है सब कुछ अच्छे से?
Yes, sir.
मुझसे एक बार करके देखो क्लास के बाद. आज तो कर ही क्या पाओगे, आज तो सो जाओगे, फिर उसके बाद करके देखना. दिवा का नेटवर्क इशू होगा, ज्वाइन कर लेंगे. Now coming to energy. Energy is in SHM. Just you know what is kinetic energy. Kinetic energy is half mv square. Just put the value of velocity. You should get the kinetic energy. Okay. Potential energy is half k. It's like half kx square because Spring force is minus kx, force is m minus m omega square into x. Here they can be compared. So k will become m omega square. So like that I can write potential energy as half m omega square x square. Total energy, if you see, it will be the sum of them. Kinetic energy plus potential energy. It will be always a constant value. See, this part is over. Now, do you want me to give you more questions on this so that you become comfortable? Because last class I have given 3 or 4 problems to you on this. Or should I move on to the next part? जीवा का माइक बात नहीं कर रहा लगता है.
Some more questions.
Questions na? Okay. Let me give you questions
So
on
when
this.
can we move up to the energy types?
See?
So the kinetic energy part. Thank you, sir.
Okay. Well, let me give you some question. I do this one. Okay. Solve this.
3/2.
Correct. What about others? देवा आंसर आया? कनिष्का आंसर आया? क्या हो क्या गया ये क्वेश्चन? ये इतना इजी इजी है, तुम लोगों को इतना टफ क्यों लग रहा है? व्हाई यू फीलिंग इट वेरी डिफिकल्ट? Do you want me to solve?
Yes, sir.
अच्छा वेट, selected the question. So what is given when the potential energy of a particle executing simple harmonic motion is 1/4 of maximum value during the oscillation? Uh, Potential energy of a particle executing simple harmonic motion is half m omega square x square, where x is the displacement. It's 1/4, given it is equal to 1/4 times of the maximum value. The potential energy is maximum when x is equal to a, na? Because the maximum displacement that it can have is a. So its maximum value will be half m omega square a square. The displacement from the equilibrium position in terms of amplitude a they are asking. So we'll just cancel that out. Half m omega square. So x square is equal to 1/4 a square, because a is a. So x is equal to a/2. This much was the answer for the solution. See how easy it was. दीवा समझ में आया? Understood this one now? Diva is not there. Kanishka, तुम्हारा हो गया था ये? You understood ना this one if you have not solved it?
तो ये मेरा हो गया था।
Okay. अब ये वाला attempt करो. Try attempting this one. Haripriya, you do it. Do this one. Diva, what happened? Did you understand this one? The solution that I have done. कुछ तो नेटवर्क इश्यू है दीवा के साइड में.
Sorry, there are network issues. Can you just quickly explain what happened in that question?
See, in that question, what they have given, potential energy of particle executing simple harmonic motion is 1/4 of the maximum value. Potential energy, we know it is half m omega square x square. And it is 1/4 of the maximum value. When the potential energy will be maximum? When x is maximum. And what is the value of maximum x? Amplitude. So half equation that you will be forming is half m omega square x square is equal to 1/4 of half m omega square a square, maximum value of the potential energy. So you will cancel them out and you will get x square is equal to 1/4 a square. So x is equal to a by 2. Okay, understood?
Yes, sir.
It's easy. Now try this
So
one.
it is 3e/4.
See, Aditya is doing very fastly now. 3/4 is the correct answer. Let me select more questions, and by the time, let's see if they are able to solve or not. I'm giving you similar kinds of questions. After you become comfortable, I'll give you different kinds. Quickly solve it and say what whether you're getting both Eva and Kanishka, you're getting the answer 3/4 or not.
Yes, sir.
Okay,
So, same answer.
same answer, no? Eva, tell me you're getting the answer or not.
So will it be a/√2?
A/√2. Let me check. A/√2.
Sir, I'm not able to do.
Not able to do. This one B. Wait. Total energy is given. Total energy is E. We know that total energy in a SHM is half m omega square into a square. Then the kinetic energy when displacement is half of its amplitude. Kinetic energy C. Kinetic energy, total energy is E, it's given. Kinetic energy is half m omega square into a square minus x square. This is the value. And they have given displacement is half of the amplitude. So what will be half m omega square into a square minus a square by 4. So again half m omega square into a square by 4 into 3. So it will be 3/4. You actually do not remember these formulas, that's why you are facing problem.
Yes, sir. That's right.
You just write these formulas. Total energy is half omega square a square. Kinetic energy is this. Potential energy also, let me write it. Potential energy is equal to half m omega square x square. These three formulas you should remember.
For this one is it a by root 2.
Correct. Kanishka, did you get the answer? A by root 2 for this one?
Yes.
Okay. Now take this question. Try this. You are able to understand this question now?
I understood, but what is phase difference?
You know this one now? See, whenever we talk about phase, y is equal to a sine omega t is there, na? Sometimes the equation may not be this. It will be a sine omega t plus some angle. This thing, the thing inside the sine, the angle, is known as phase. This is phase 1, phase of the first wave. This is the phase 2. And the phase difference, delta phi, is actually the difference of these angles. Omega t plus theta minus omega t. So it will be theta. So basically phase difference is the difference of the angles. Now you will be thinking this question sir ने जो दिया है, this question is tough, it's not easy.
So could you solve it?
See what the question has given. Two particles are executing SHM of same amplitude and frequency. Means their amplitudes are same. Omega is also same. They pass one another when going in opposite direction. Each time their displacement is half of their amplitude. means when they are actually meeting at this point. X is equal to a by 2. One going right, then other will be going left. Phase difference they want. See, now for both of them actually the displacement, why I'm writing y, x now. For both of them the displacement x is equal to a sine omega t if we take. Acha, this we can do how? Because if we take the general equation as x is equal to a sine omega t, it will be x is equal to a by 2 because they are meeting at a by 2. A by 2 will be a sine omega t. Now you just have to see when at what different angles I get sine omega t as half. Omega t, one value is omega t is equal to 30 degree. Other sine of 90 plus theta. Sine 90 plus theta. Sine is positive in the second quadrant. It's cos 60. So the other angle is omega t is equal to 150. 120 degree. You understood? So the difference is 150 minus 30 is equal to 120 degree. This is our answer. Haripa, did you understand how I solved it?
So I got it till sine omega t is equal to half, and then I lost.
See, what is the problem now? Acha, better you take it as a circular motion. Let's take it like this. This is a circular motion. This is doing simple harmonic motion like this. Okay? Now you will better understand this way. This is the mean position. This is A, amplitude. The particle, they have said one particle is moving like this, other particle, they both meet at x is equal to a by 2. When they're moving away, means moving in different directions, right? Means they are meeting at a by 2. This distance should be a by 2, right?
Yes, sir.
Now this is a by 2, this is a. Can you tell me what will be this theta? Means when the particle is,
It would be 30 degree.
because he is moving, the particle is moving like this now. left, going left.
One left and one.
One left, and this angle will be 30 degree now. But now when it will be, it has come here like this, and again it's going like this. Or the better way, what I can do is, there are two positions. If the particle has started from here, is moving like this. So one point is this. One particle is moving towards right, one particle is moving towards left.
Yes, sir.
If this is 30, theta is equal to 30 degree, can you tell me what this angle is?
Sir, it would be. Is it excluding the other one or including the other?
Excluding the other one? No.
No.
I want all those positions when the particle is, see, the particle is starting from this position here. It is starting like this. You see, you take like this. It's starting from this. I should not take this angle like this. The particle is starting from this vertical position, mean position. When it has moved here, how much angle it has traveled? How much angle it is? 30 degree. Now again, when the particle has moved like this here and then came back to upper position, how much angle it has further traveled?
150.
150, na? Because this angle is also, this is theta 30, and this is what? This is 60 degree.
Yes, sir.
60 degree. 6, 30, and this is again 30. No, there's some mistake. $150 degree it is, or what? 30, this is 30. A by 2, no. Wrong calculation, I think. This motion.
120.
This angle it has traveled, so it comes out to be, this is A by 2, this is A sine 30, and this is 30 degree only. Now it is 90 degree, and again by this we are getting different angles. Acha, sorry. Again, I should get this angle as 150 degree total. I am not getting it. 30 plus 60 plus. This is 30 or what? 30 is correct only, na? Why you said this is 30? It's 60 degree, na? That's why we are getting confused.
Yes, sir.
This is 60, this is 30, this is 60. So at this position when it was moving right, this was theta is equal to 30 degree from the vertical position, and then again when it is coming back, this is theta is from vertical position, it is theta is equal to 150 degree. So the difference, what is the difference of the angle between them? 150 degree minus 30 degree. It's 120 degree.
120.
Now you understood?
Yes, sir.
Like that we solve. Yeah, just wait one minute. Someone is at the door. Hello? Hmm. Yeah. Hello. Did you understand this one? Haripriya,
Yes, sir.
did you understand this one? Diva, this was different kind of question, but I gave you because to make you understand how things are like this. Or see, I have calculated it this way just to make you understand better, because initially only I have told that the simple harmonic motion uh, can be compared with the circular motion. But if you do not bother about it, because they have given the two particles meet at x is equal to a by 2, that means the phase difference. So when x is equal to a by 2, just do it simply. X is equal to a by 2. At what angles it's possible? So sine theta omega t is equal to half. So it is possible at omega t is equal to 30 and omega t is equal to 150 degree. So the difference of these two angles gives you the answer. That's the easy way of solving it. Let me give you one more question. Try solving it.
The result option D.
And D. Hmm, 0.62. Correct. What about others? Haripriya, you can leave. Because today I won't teach you any more concept because time is over. In the next class, I'll teach you how to find out the time periods. There is a method. Two different methods are there. So in the meantime, I would suggest you to revise them. The way I have told you, na, try deriving by yourself. Y is equal to a sine omega t using that velocity and all.
Okay, sir. Thank you, sir. Bye, sir.
Bye bye. Now, what about Diva? You're getting answer? Kanishka?
Yes, sir.
Kanishka, आगे answer? Okay. You can leave also.
Sir, we different
हैं? तुम्हारा आंसर नहीं आया?
No, sir.
सॉल्व करके दिखाऊं?
Yes, sir. Yes.
हम्म, इतना मुश्किल है नहीं, तुम्हें लग क्यों रहा है इतना मुश्किल ये दीवा? तुम एक बार वही रिवाइज कर लेना इसको, है ना? रिवीजन से बेटर पता है क्या है, कि तुम उसको वो कर लो, जैसे मैंने बताया ना अभी, हरिप्रिया को बता रहा था, वैसे ही करके खुद से ड्राइव करने की कोशिश करो तो हो जाएगा। देखो सॉल्व करते हैं। डिस्प्लेसमेंट ऑफ पार्टिकल इस तरह से वेरी हो रहा है, वो हमें दिया हुआ है y इज इक्वल टू साइन पाई टी बाई 4 प्लस पाई बाई 6। मैक्सिमम एक्सीलरेशन ऑफ पार्टिकल पूछा है। अब इसको अगर अपन कंपेयर करें तो y इज इक्वल टू ए साइन ओमेगा टी प्लस थीटा से कंपेयर कर सकते हैं इसको, है ना? इसमें a क्या है 1, ओमेगा है पाई बाई 4। हरिप्रिया ने इसको ऐसे ही सॉल्व किया होगा। और हमें पता है कि मैक्सिमम एक्सेलरेशन क्या होता है, ए मैक्स इज इक्वल टू, तुम्हें प्रॉब्लम पता है इसीलिए हो रही है, तुम्हें फॉर्मूले याद नहीं है ना, उसने सामने रख दिए होंगे फॉर्मूले। ए मैक्स इज इक्वल टू ओमेगा स्क्वायर ए है, ये अपन ने निकाला है ओमेगा स्क्वायर ए प्लस और माइनस। आज तुम्हारा नेटवर्क भी खराब गड़बड़ था, तो जब जस्ट वैल्यू पुट करनी है, पाई बाई 4 होल स्क्वायर इंटू एम्पलीट्यूड 1, तो ये हो जाएगा पाई स्क्वायर बाई 16। पाई स्क्वायर की वैल्यू 9.8 होती है, इसको तुम 10 ले सकते हो, 10 बाई 16 5 बाई 8 0.6, हाँ 0.62, यही है डी।
Yes, sir. Yeah.
है ना? अब तुम्हें पता है प्रॉब्लम इसलिए होगी क्योंकि ये वाला सिर्फ ये फॉर्मूला तुम्हें याद नहीं होगा, है ना? इसलिए एक बार फॉर्मूले याद कर लो, देख लेना, एक बार फॉर्मूले खुद से डिराइव कर लो, याद हो जाएंगे। देखो मैंने बताया था ना ए मैक्स इज इक्वल टू प्लस और माइनस ओमेगा स्क्वायर होता है, क्योंकि मुश्किल क्वेश्चन मुश्किल है ही नहीं, इजी है। ठीक है, तरीका क्या है, कैसे करोगे, एक्स इज इक्वल टू ए साइन ओमेगा टी, इससे स्टार्ट करना, फिर वेलोसिटी डिफरेंशिएट करके निकालना, एक्सेलरेशन डिफरेंशिएट करके निकालना, और फिर उसके बाद देखना कि वेलोसिटी मैक्सिमम कहाँ कहाँ पर होती है, एक्सेलरेशन मैक्सिमम कहाँ कहाँ पर होता है, वैल्यू क्या होती है, अपने आप डिराइव करोगे ना, अपने आप आ जाएगा खुद से। ओके चलो फिर एंड करते हैं ना,
Bye, sir.
बाय बाय।